how do I do this? Well, it turns out that that's got to be one of the largest errors that is going on in our understanding of physics and our understanding of the way the universe functions and our place in it. That is, that infinity and finite system are opposites instead of complementary. But how can a finite system and an infinite curvature be complementary? How can the two be together? I knew when I was 10 that there was a solution to this, because I knew I was right, because I had seen it in my mind's eye. I instinctively knew it. Actually, most children I talk to, if they haven't gone through that first lesson of geometry, know this. They think of the universe as infinitely big and infinitely small, all embedded into each other to infinity. In general, they think of that as being quite logical. The kids are not the only people that thought of this. Do we have sound on the computer? One famous physicist, Carl Sagan, wrote a book called Contact. And then there was a movie that was made out of that book. And the movie starts like this. Okay, this is a little bit hard to see. It's the edge of the Earth. There we go. And so we're moving away from the Earth in space. And as we move out, we catch up with all the radio waves that were sent into space by the Earth. So it's like almost going back in time. There goes Saturn. Now we're exiting our solar system. And shortly we'll be exiting the arm of the galaxy we're in. Here's our galaxy center. Now we're moving faster and faster away from our galactic supercluster. So the concept of a universe within a point, was there quite definitely described. Let me tell you as well that the concept of a universe coming out of a dot is not that outrageous. The current theory of the Big Bang says that we all came out of and all of our universe. The only difference here is that this view says, no, it didn't all emerge from one dot that decided to make a universe. All dots contain the possibility of a universe in it. All dots are connected to all other dots. And so here, then Hollywood came up with their version of this concept. And since they're the man in black, they have much faster technology. They can move much faster than anybody else. So that's the end of Man in Black movie. They have extreme speed. Because they got all that alien technology. Little marbles we are. So these concepts have been around, except they've never really been understood because, again, how do you fit infinity in a finite space? And it's crucial that we understand how we did it. Well, when I grew up, eventually, I found the solution. I found the answer to this. The solution is what is called a fractal. And I'm going to show you very, very simply how infinity fits into finite. How infinity and finite systems are absolutely complementary. And that each point has the potential of having all information in it. I'm going to show you this in a geometrical way, so it's really easy to understand. And it just happens that the way I'm showing you this turns out to be very crucial to the way systems are organized and generate the geometry of our reality everywhere we live. So we're going to make a boundary, a circle, and inside it we're going to inscribe a tetrahedron, or an equilateral triangle in this case. The boundary could be a sphere, and the middle triangle could be a tetrahedron. Okay? So this you can visualize in 3D space, in spherical coordinates. Now, the universe is polarized. Positive, negative, male, female, white and black. So this has a polarity, right? And generates a reverse equilateral triangle. Now, I'll give you a hint to the ancient civilization part of this lecture we're going to have today. Right away, we have one of the most commonly found symbol in all ancient civilization around the world. A circle with a double triangular polarity inside it, commonly referred as the Star of David, or the Shield of Solomon, the Star of Zion. It's found on many walls around the world of ancient civilization. Now, if you keep adding triangles, you get smaller stars of David. And then you can keep adding them again, and you get smaller stars again. Now, at each level of the fractal, you're going to generate a boundary. This is an important part to understand. Each level generates a boundary. Again, boundaries at the next level. And now I'm making smaller boundaries. See, I didn't put them all around because I got lazy. And then now I'm making smaller boundaries again. And smaller, and now they're so small you can't see it. Now, if I give that equation